everyone, welcome back to the channel. So today in this session we are going to discuss artificial intelligence min-max search algorithm. I will share with you its introduction as well as some important principles that will help you get a clear idea about this algorithm. So now let's just start the session. So students, min-max search algorithm is nothing but it is a popular or fundamental decision making algorithm used in AI, and basically this min-max search algorithm is widely used in two-player games and other adversarial scenario. If we talk about two-player games, we have some examples like chess, checkers, tic-tac-toe. We all play Ludo with two people only, right? So all these uses min-max search algorithm. Also, it helps determine the optimal moves. ऑप्टिमल मूव्स मीन्स द बेस्ट मूव जिसकी मदद से हम गेम को विन कर सकते हैं. सो इट हेल्प्स अस इन डिटरमाइनिंग ऑप्टिमल मूव्स फॉर अ प्लेयर by assuming that both players play optimally. As you can see here, it is a decision making method used in AI, especially in adversarial game playing applications. It is a recursive algorithm. This particular thing is very important. So min-max search algorithm is a recursive algorithm that evaluates possible moves in a game to determine best strategies for the players. The min-max algorithm evaluates all possible moves in a game to identify best moves for the maximizing player. We have two types of player here. First can be your maximizing player, or another can be minimizing player, that is your opponent. Okay, it alternates between maximizing and minimizing values as it traverses the game tree. So one thing that I want to share with you, that min max search algorithm always follows a game tree rule. So if we talk about its core principles, so the first core principle is game tree. I will discuss every point in detail. Another is players, evaluation function, and backtracking. So if we talk about game tree, so it represents all possible states of a game starting from the current state, and each node, that is each participant, corresponds to a game state, and each branch represents a possible move, that is the game tree. Another is players. So we have two types of player. First is your maximizing player and another is your minimizing player. So if we talk about maximizing player, it attempts to maximize the score. All right. For example, AI aiming to win here. So it attempts to maximize the score. And if we talk about minimizing player, so it attempts to minimize the score. That is opponent trying to counter. All right, everyone. Next we have is evaluation function. So it assigns a numerical value. It assigns a numerical value to each game state, representing how favorable it is for the maximizing player. It can also terminate the states. All right. Next is backtracking. So the algorithm computes the optimal moves by backtracking from the terminal states of the game tree to the root. All right. So all these are four core principles under your min-max tree. Again, if we talk about evaluation function, it uses terminal state, right? It uses terminal state like win, loss or draw. These three are the terminal states here, जो कि final score पे depend करता है. Let's take an example of two-player game where the maximizing player has, let's say, three options leading to score, that is 3, 5 and 2. And minimizing player counters by selecting the smallest score among its option. So minimizing प्लेयर जो होगा वो मिनिमम जो स्मॉलेस्ट नंबर है उसको सेलेक्ट करेगा. एंड इफ वी टॉक अबाउट मैक्सिमाइजिंग प्लेयर तो वो 5 को डेफिनेटली सेलेक्ट करेगा. So the min-max algorithm evaluates all possible outcomes to determine that the best move for maximizing player is the one leading to score 5. We have some time complexity over here. So first complexity is our time complexity, that is OBD, where B is the branching factor. We have discussed it uses game tree. So B is there, that represents the branching factor. Branching factor means the average moves per state. All right. D is nothing but D is the depth of that tree. This is the time complexity. Another we have is its space complexity. It is B into D, as it uses depth first search algorithm. It uses depth first search algorithm. So depth first search algorithm में इस केस में इसकी space complexity जो है वो multiplication से हम use करते हैं. Now one more thing that I want to share with you is the applications of min-max search algorithm. So I am writing it here. Applications of min-max search algorithm is your board games like chess, tic-tac-toe, checkers, etc. Another application can be strategic decision making. It is basically used for strategic decision making where we have more than 2 to 3 options, but we have to select only one. Another is artificial intelligence, game engines, and bots. All clear? So students, I'm now going to conclude this session that min-max algorithm is a cornerstone of AI that enable rational decision making in competitive environments. All right. Other than these applications, I will share with you some benefits of using min-max algorithm in AI. First benefit is the optimal decision making that we have discussed so many times in the session. Let me write it here quickly. Okay, so optimal decision making. Another is simple. This process is very simple and intuitive. That means this algorithm follows a clear and straightforward process. Another is its flexibility. It can be applied to a wide range of games and decision-making scenarios like board games. So it gives us a flexibility of coding or selection of the results. Another is predictive power. So as this algorithm uses depth first search algorithm, so it ensures that all possibilities are explored clearly. Right, next is the clear strategy. Min-max search algorithm uses clear strategy by evaluating every possible scenario. So these benefits helps all these benefits are the foundation for min-max search algorithms. So I hope students everything is clear to you. If you have any doubt, you can definitely comment below, and other codes and related terms we will discuss in the next session. So thank you so much.